Tensors. This tool introduces you to the concept of tensors. Tensors are a fundamental concept in AI and machine learning that can be thought of as multidimensional containers for data. Most of us are already familiar with scalars, vectors, and matrices. Tensors can be seen as a generalization that encompasses all of these concepts along with higher dimensional data structures. They serve as a versatile term to represent various data types and containers, allowing us to work with more complex and multidimensional datasets. Imagine a matrix representing a grid of numbers, where each number represents a value. Tensors expand this idea to any number of dimensions, allowing us to store and manipulate complex data structures. Just like a matrix can represent an image or a table, tensors can hold vast amounts of information, such as pixel intensities in an image, stock prices, and insurance data. Tensors enable us to process and analyze this data, allowing machines to learn patterns, make predictions, and solve real-world problems through algorithms like neural networks. Let's consider another simple example. We are generally familiar with XY data and how this data can be represented by a simple regression line, such as y equals ax plus b, where a and b are calculated to best fit the data. To expand this concept, the output, or the dependent variable, can be a function of two independent variables, x1 and x2, instead of just one. This is how we can express this relationship. Y equals a1 x1 plus a2 x2 plus b, which can be expressed in vector matrix tensor form as y equals xa plus b. Here, y is a vector of size 3, which is equal to the number of samples. X is a set of two vectors, x1 and x2, which can be represented by a matrix of size 3 by 2. The model parameters a1 and a2 can be expressed as vector a of size 2. And finally, b can be expressed by just a number or a scalar. To make things easier, all these different types of data can be expressed by just the tensors of different shapes. This tool will help you understand the concept of tensors. Let's explore it. In this first section, View Tensors Examples, we explore how different tensors can be expressed visually. So this includes their shape, rank, and what mathematical entity they represent. The rank of a tensor indicates the number of dimensions, while the shape of a tensor describes its size in each dimension. Let's start with the tensor of rank 2 by selecting it here. So go here and I can select rank 2. Its rank is 2 because the dimension of the data is 2, which means that we would need two independent numbers to locate each number of the data. In this case, the row number and the column number. To express this type of tensor in code form, there will be two sets of nested square brackets. The shape of this tensor is 2, 4, which means that there are 2 rows and 4 columns. The rank is 2 because this is two-dimensional data. In mathematics, this type of data type or container is called a matrix. Let's explore what a tensor of rank 3 looks like. This particular tensor of rank 3 is a set of 3 matrices, and each matrix has 2 rows and 4 columns. So the shape of this tensor is 3, 2, 4, which we can read as 3 matrices with 2 rows and 4 columns each. Similarly, the same concept can be extended to higher dimensions, like tensors of rank 4, like this, or the lower rank tensors like rank 1, which is equivalent to a vector. And we can even take a look at rank 0 tensors, which is equivalent to a scalar value like the number 3. In this next section, creating a tensor from raw data, we can see how a simple one-dimensional data can be transformed into the tensor of any rank. For example, Here is the raw data of integers from 0 to 15. If expressed as a rank 2 tensor, we have this tensor of shape 2, 8. Other shapes are also possible, such as 4, 4, or some others. This is how the value of this 2, 8 shape tensor are represented as code. We can transform the same data into a rank 3 tensor. So we can click this and select rank 3. Now, this rank 3 tensor has the shape 2, 4, 2, and a rank 4 tensor has the shape 2, 2, 2. In the next section, real-world tensor examples, we explore some interesting real-world examples where tensors are used to effectively express the data. In all of these examples, the first dimension always represents the number of samples, and the remaining dimensions represent the data dimensions. Let's select the rank 2 example, and we can see this is an example of insurance risk data. The two dimensions here are samples and features, or data characteristics. These data characteristics are age, zip code, and the income of the insured, which are shown here in these columns. This data can be represented and displayed as a graph plot. Here we show this data as a tensor with its values and shape. Notice that there are 4 rows, and within each row there are 3 elements. So its shape is 4, 3. Now let's select rank 3, for example. This is the data for a stock price. The 3 dimensions here are samples, timestamps, and features. The timestamps can be expressed as sequence numbers, and the data characteristics, or features, are open, high, low, and close stock prices. This is how the data can be represented visually, and here it is represented as a tensor, with 2 data samples as the outermost brackets. Each sample has 6 sequences, and each sequence has 4 data features. The shape of this data is 2, 6, 4. Similarly, we can examine the rank 4 example, which is image data with dimensions of samples, height, width, and color channels. The rank 5 example is a video clip example and is very similar to rank 4, except that it adds a new dimension of frame count. Here you can see its visual and tensor representation. This covers how this tool can be used to understand the concept of tensors and what their shapes and orders mean, as well as some real examples of tensors. Please feel free to try out the tool by using different tensors and analyzing the tensor attributes.